Okay, so we are going to solve some problems. And we are going to be looking at word problems here. Some of these are the same problems that we used, like if they look familiar, so I'm sure you guys remember things like this. I took some problems like from our college algebra units. So some of these problems we've actually solved before, but we did it in a different way back then. We were talking about like quadratics, and we know that if you have a maximum on a quadratic, what point does that happen at? What's the graph of a quadratic look like?
That one?
Parabola, yeah. So it either looks like this or this. So if I want the highest or lowest, what are you finding? The maximum. What's the
points? No. Oh my gosh.
So in like algebra 2 or college algebra, what would we have called that point? A vertex.
Oh.
And so we did those problems back then. We only had quadratics and we could deal with the vertex. But now we know calculus and we know this point is a critical point. So what's the derivative here? 0. So we know we can find maximums or minimums just by finding where the derivative is 0. And so we can extend it to something beyond a quadratic because we can find those points. So our strategies here, we always have to figure out what the problem's asking, figure out what we need to maximize or minimize. We cannot solve problems with x's and y's in them. So we can't have multiple variables. So everything has to be in terms of one variable. Then we'll find our critical points, get the maximums or minimums. And in a word problem, how do I want you to answer it? In the sentence. Okay. So let's look at a problem. So a farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. What dimensions will maximize the area of the pen? So what should we do? Picture. Okay, so we have a wall, and we are going to put this pen around it. I do not know these sides. I would know these two would have to be the same, so I could call both of these x. And that one's different, so I'm just going to call it y. But we know in terms of solving this problem, we can't have x and y. I do expect you to define your variables. If you draw a picture, that counts. If you don't, then you would have to say x is the width of the pen and y is the length of the pen, and specify there. What information do we know in this problem?
It would equal up to 200 yards.
Right, 200 yards is the amount of fence. That's like the perimeter. So it's saying if you add those 3 pieces of fence, it has to equal 200. So we can use this to solve for y. I'm not getting a number, but I now have y in terms of x. So instead of y, I'm going to call this side 200 minus 2x. What am I trying to maximize or minimize here?
Area.
Area. How do you find area? So that would have been x times y, but now instead of y, I'm going to replace that with 200 minus 2x. So if we distribute, the area is 200x minus 2x squared. Anytime I ask you to find the maximum or minimum, what do you need? So we need to find the derivative. So we're back to nice, pretty derivatives. These are polynomials. So derivative of 200x would be 200 minus derivative of 2x squared is 4x. And what do I want to set that equal to?
0.
I tried to give you guys blank slides after these two, so you have a little extra room to work. So we could add over the 4x, divide by 4, and x is 50. Am I done? What do I need to do? Yep. My question said what dimensions, so we should write a sentence. So the fence should be 50, we were in yards, by, that was x, so the other side, 200 minus 2x, so 200 minus 2 times 50 would be 100. So please answer a sentence. You could say, you know, the width is 50 yards and the length is 100 yards. You just have to write some kind of sentence to answer the question. Sometimes we might get answers that don't make sense. Like if I'd gotten a negative, could we have a negative length? No. So we do have to, sometimes we might have more than one critical point and we'll have to check to see which ones make sense in our problem. Is that okay? So I want you guys to try to set up the next one. I gave you a very similar problem. Sorry. Okay. Go ahead and try that problem. So we are building a rectangular corral. So we need a rectangle. I think everybody has that. But then I'm going to break it up. Some of the fence is going to make two inner divider fences, both parallel to the same sides of the corral. So I have two fences in here breaking it up. Doesn't matter which way they go, they just have to be parallel to each other. So something like that. What do you know about all four of these lengths?
Same.
So pick a variable. Let's say I call those all x. What would I call these two then? Y. They are different. We have 1,000 meters of fence. So what should we do?
So equals 1,000.
So we have 4 x's plus 2 y's equals 1,000. We have to use this to get rid of one of the variables. It doesn't matter which one. Let's say I wanted to solve for y. So we would have to subtract over the 4x. And then we need to divide everything by 2. So 1,000 divided by 2 is 500 minus 2x. What am I trying to maximize here? Area is just length times width. Doesn't matter that we have those divider fences just in the big rectangle, x times y. But I am going to replace that y with 500 minus 2x. That gives me 500x minus 2x squared. Now what? We want to maximize, so we need the derivative. So derivative of 500x would be 500 minus 4x. And when we maximize, we set that equal to 0. So we get x to be 125. So answering the sentence, I wanted to know what is the maximum possible total area. So I don't even care about the dimensions this time, I just need the area. You can find that different ways. You could find y and do x times y. You could even just plug your 125 in, you know, up here to our area equation. So any way that we do that, so I'd have 125 times 500 minus 2 times 125. So the maximum area is 31,250. Area is square units. Were we in meters? I think square meters. All right, so the picture was a little bit different, but the idea was the same then. We had a rectangle, area of a rectangle, length times width. Do your derivative. Are we okay with that problem? The next one, I want to go to one of my favorites from college algebra. Remember when we had those problems where I'd say, okay, you've got a rectangular piece of cardboard and you're going to cut out the corners and fold it up to make a box? I don't remember these problems. I really love these problems. Okay. A piece of sheet metal is rectangular, 5 foot wide and 8 foot long. Congruent squares are to be cut from its 4 corners. The resulting piece of metal is to be folded and welded to form an open-topped box. How should this be done to maximize volume? So what should we do? So I'm starting with a piece of metal. And I even know the dimensions of that metal. It's a rectangle. My width is 5. My length is 8. And then I'm going to come in and I'm going to cut the corners out of this. Okay, so essentially when I cut those corners out, then you are left with a piece of metal that looks like that. And so then those 4 sides really create 4 tabs that you could then fold up to create your box. Can you guys visualize that? So we are going to get a box out of this. All right. Do we know how big these squares are that we're cutting out? No, that's what we're trying to find. So we do know it's a square, so both of these are the same. So these are just x by x. All right, so if you think about this, you have this piece of metal, and it was 8 feet long. And so then I cut off a corner here and a corner here. So it is no longer 8 feet long. How long was each of those pieces that I cut off? X. So I took off X on this end and X on this end. So how long is it now? 8 minus 2x, because we cut off 2 sides. Okay, same thing on the short side. It had a length of 5, but I removed a square on each end. So how long is it now? 5 minus 2x. Okay, so then I create this box by folding up those sides. How tall is this box when I fold it up? X. The height is just the width of that tab. Right, I am talking about volume. How do you find volume? Length times width times height. So we have to multiply these. So x times 8 minus 2x times 5 minus 2x. We're trying to maximize, so that means we'll need the derivative. But it would probably be best if we multiplied this out first. I'd rather do the derivative of a polynomial than product rule 3 times. So if I FOIL the two parentheses, we get 40 minus 16x and minus 10x, so minus 26x plus 4x squared. Distribute the x. All right. So then, what do I do? Derivative. 40 minus 52x 24x squared. And we want to ultimately figure out when this equals 0. Is there anything we could do to help with that? I think we, oh, it's a quadratic. Let's pull out the 4 first. I'm going to go ahead and flip this around. I'm going to put the x squared first. So that would be a 6x squared.
Why would 4x squared be 8x?
Should be 4x cubed, shouldn't it? Sorry. Did you guys see my mistake? When I distributed my x, for some reason I changed that to an 8. That should just be a 4. So then my derivative, that would be a 12. Okay, thank you. I think we could still take out a 4 though. What would we have to do in here? So I need two numbers that multiply to 30 and add to negative 13. Make 10 negative 3. So we have 4 times x minus 1 times 3x minus 10. Then what do we do? Does 4 ever equal 0? No. Okay, so then we have x equals 1. If you set 3x minus 10 to 0, you get 10 thirds. Okay, so I got 2 answers. We need to make sure both of these will work. So is it possible that if my metal is 5 feet wide, could you cut 1 foot off each end? Yeah. Okay, if it's 5 feet wide, could we cut 10 thirds off? That's like 3 1/3. If I cut it off one end, yeah, that would be altogether cutting off 6 2/3. I'd be cutting off something more than I have. So the 10 thirds will not work here. The question was, how should this be done to maximize volume? So, squares should have sides 1 foot long. Or you should be taking off 1 foot on each end or something like that. Used is a lot of applications with business and economics. One reason why a lot of business majors have to take calculus. So thinking about some econ stuff. C of x is the cost function. We've seen that before. We've talked about cost, marginal cost, those kinds of things. So that's cost of producing x units. We know marginal cost is the derivative. It's how the cost is changing at a particular time. So that's something that we've seen before. The marginal cost function is the derivative of the cost. Okay, but in marketing, you're not only concerned with cost. You have to take into account not just how much it costs you to make something, but how much should I charge people to buy it? You know, what kind of profit am I going to make? So we are going to talk about demand functions, or the price function. How much should I charge for my product? You know, it costs me $5 to make it. Obviously, I have to sell it for more than $5. But we know that if we charge too much for it, what's going to happen? Nobody will buy it. So I have to find that magical number because I want to charge the most that I can where people will still buy my product. All right, so we'll talk about revenue. Revenue is the amount of money you're bringing in, so that's your price times your quantity. So if I'm selling them for $10 each and I sell 5, how much money did I bring in? $50. Okay. Now, is that the same as my profit? No. Revenue is what you collect. What would you have to do to find your profit? Subtract off your costs with it. Okay? So just like the derivative of cost is marginal cost, the derivative of revenue is your marginal revenue. That will tell you how your revenue is changing. And we know then profit, a lot of times for profit, your book uses capital P. And so that would be your revenue minus your cost. The amount of money you bring in minus the amount of money you spent to make your profit, or to make your product. Marginal profit is just your derivative. That tells you how your profit is changing. So we will just do one problem, and then we'll pick up with some more of these tomorrow. So there's lots of questions I can ask you with these. We can talk about the cost, we can talk about the revenue, we can talk about the price, so there's a lot of things that we could look at. This one says, suppose the cost of publishing a book is $10,000 to set up the press run, plus $8 for each book printed. If you just have that information, let's assume this is linear. Could you write the equation for the cost? What's the 10,000 represent? Yeah, it's your starting price. It's like your y-intercept. Then you have to pay $8 for every book, so that's like the slope. So what would my equation be? $8 for each book, so 8 times the number of books, plus that $10,000 for setting up the press. Okay, the publisher sold 7,000 copies last year for $13 each. But sales dropped to 5,000 copies this year when the price was raised to $15 each. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed, and what should be the selling price of each copy to maximize the year's profit of the book? All right. So I have my cost function. This information is $13 my cost to print the book? No, what is that? The price of the book. We know from this that X has to be the number of books that we printed, right? So if I wanted to talk about the price, we could look at some ordered pairs. When I print 7,000 copies, so that would be my X, my price was $13. When I print 5,000 copies, my price was $15. And again, the reason that my X had to be the 7,000 and 5,000 is in the cost equation we wrote, X was the number of books printed. So we have to keep the X the same throughout the problem. So X has to continue to be the number of books printed. So could we write the equation for price? Yeah, we have 2 points. We can write the equation of a line. We need the slope. So slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my slope is negative 1 over 1,000. So to write the equation, you pick one of your points and your slope, plug into y equals mx plus b. My intercept is 20. So this means my price equation. It's kind of confusing. Your book uses capital P for profit and lowercase p for price. So just be aware of that. So my price, my lowercase p, is negative 1 over 1,000 x plus 20. So far, we know an equation for the cost to print it, and we know an equation for the price. We are trying to maximize profit. What is profit? Close. Profit is revenue minus cost. All I have is my price, but revenue is your price times your quantity. The amount of money I bring in is how much I charge for it times the number I sell. So my revenue is x times p of x, or x times that equation I just wrote. We get negative 1 over 1,000 x squared plus 20x. So we are in pretty good shape now because we want to maximize profit. Profit is revenue minus cost. So my revenue is negative 1 over 1,000 x squared plus 20x minus my cost, which was 8x plus 1,000, or 10,000. Have I lost anyone? It's a lot of things to keep straight. Revenue, price, cost. So, this is my profit equation. 20x minus 8x would be 12x minus 10,000. Then if I want to maximize my profit, what do we have to do?
Or do we do it?
Mm-hmm. And once we find the derivative, we set that equal to 0. So if I multiply over my 500, I get 60,000.
6,000 or 6?
Sorry, 6,000. So I asked 2 questions. I wanted to know how many copies should be printed, and we already said X was the number of copies. So there should be 6,000 copies. And I asked what the selling price should be. So we need to know how much we should charge for them. If I'm asking how much I should charge for them, is that profit, revenue, cost, price? What is that? Price. We have a price equation right here. So if we plug in 6,000, I get -6 plus 20, which is 14. So I just plug my X into my price equation that we had. We should charge $14 each. This will make the most money for me, because if I charge more than 14, I'm not going to sell as many books. If I charge less than that, then I'm not making the most on each book that I could. That would have a lot of parts. I know, we will be doing more of those, okay? So I'm stopping here today. We have like 12, 13 minutes left. I think I printed an assignment at the end, but we are not ready to do all of these yet. So why don't you guys do 3, 7, and 15 for today? Okay, since you guys did do the homework from the last section, I'm not going to collect this tomorrow. We will add to it, but you want to be working on it.